morning, ma'am. Hi guys, we are team 4, myself Ashwin, Karthi, Ajay, and Lilian. So we are here to explain about GANs. So GANs is operation of generative adversarial networks. Okay, most of you might have used Face app. Remedy you have used anyone? It is a quality improving app. Okay, Face app is something you give for creating different phases, right? So this is something related to that. So I have been scrolling in social media. So I have saw a video that it generates a website generates an art or logo or any other thing where if you give an information by itself. So GANs are very useful in present day technology. It is a little creepy because artificial intelligence itself is a little creepy one because it can produce a lot of jobless opportunities. So, first we come to introduction. So GANs are different from other deep learning networks because other deep learning networks use supervised learning. Supervised learning means using labels for mentioning like CNN. Okay, CNN we use cars as a label, lorry as a label. So we classify them as to many subdivisions. So we don't use supervised learning in GANs. So that is the main advantage of GANs. So one more thing what we have done is creating an avatar. So you heard it right. Not the avatar that was released recently. Avatar is the profile or icon. Okay. So in games, in social medias, you might have seen the avatar, right? So each player or each character gets an avatar or photo. So we have provided the data set and we have created a new avatar for each player or new profile created. So the agenda of our program is we will discuss about the generator and discriminator, flow of control, data set, prerequisites for our program, about the project and last conclusion, and we also discuss the problems that we are facing.
There are two models, generator and discriminator. The generator itself defines something generated. So generator generates something fake on given input. So input can be matrix or vector. So generator can use any type of network to generate fake images. And second type of model is discriminator. So discriminator is a simple classifier. It's used to classify which is fake and which is real images. Training the generator discriminator, we have to train the generator discriminator to generate images and discriminator, of course, distinguish between fake and real. So let us take an example. Let's take an example of robber. The robber wants to generate fake images of a currency note. If he generates a fake image of a note, there is someone who wants to discriminate between fake and real. So let us name finder. First time when the generator generates an image of new image, the discriminator tells it's fake or real. Second time it generates images which is similar to the currency. Second time it also tells it's fake. So this is how the generator and discriminator get into better ways to generate images. So this is a flow of control. This flow of control helps us to understand how the generator and discriminator coordinately works. First, the generator model will get an input, random inputs like vector or matrices, and based on inputs, it generates an example. So example and the real generator example and real example. The discriminator tries to discriminate which is fake and real. So it's an example of binary classification. It tells real or fake. After telling, it updates to discriminator model and generator model. It is equal to data set.
Hello everyone. We all know that data is very important for machine learning. Without data set, machine learning is not possible. We use data set of animated images, about 10,000 images as our data set. We can also use real-time images as our data set too, but it has about 1 lakh images as the data set. So it takes about 1 week for training the model. So as of now we use animated images as our data set. Now we see how to install and how to download and open the data set. first we install the open dataset library using a type install function. And then we input we name the URL link. We can directly log into our Kaggle account using by taking the API file and opening the JSON file. So here you can see your Kaggle username, your Kaggle key by giving input as username and the key. We can directly download the dataset from Kaggle.com. So these are the animated dataset. Before training the model, we first standardize the size of the every image as 64 to 64 pixels, and we know that every image has intensities from different intensities. So we normalize them to -1 to +1, and they are in matrix format as image tensors. So we denormalize them into image grids.
கொஞ்சம் faster.
So this is the flow of the data set. First we input the data set and we normalize into
-1 to +1.
and we denormalize into grids and implementing the GPU we will get to see training the model discriminator network. This discriminator network we will complete the two data set. We will complete the two data set and give the results either it is real or fake. The sigmoid network is if the output of the discriminator network, if it is 0, then the image is fake. If it is 1, then it is close to real.
Okay. Now we are going to see CPU. When do we want to consider CPU as CPU? We cannot do all the tasks we are doing in CPU with a GPU, and we cannot do GPU's job using a CPU. First of all, CPU is mainly used for processing and parallel processing, multiprocessing applications, whereas GPU is used for video processing and image processing applications. While we are going for artificial intelligence neural networks, we are going to process images as well as the multiprocessing. We are going to process the tasks using the CPU, and we are going to process images or videos using the GPU. Now, if you are going to use a CPU as a GPU, it will take a decade of time to complete your process and give your output. So now we are going to use the device data loader function and import it to our program, and we are going to say the program we are going to use GPU to process these images. Okay. Now we are going to speak about discriminator network and the generator network. As Karthikeyan explained, the discriminator network gets the given image with the generator is real or fake. Now we will see how this discriminator works. We have a data set of 10,000 images. The discriminator takes the grid of 8 cross 8 images from the data set. From those 10,000 images, this is the 8 cross 8 image set. Then this is the 3 cross 3 image returned by the generator network. The generator network will multiply the intensities and give an output. This discriminator network will compare each output given from the generator and the data set derived from the given input. Likewise, the intensity of the generator and the images taken from our data set matches. The discriminator return 1, otherwise it will return 0. This is calculated by the sigmoid function. Okay. Now we we are going to see how the generator network works. Like I already said, the generator network has to feed on a 8x8 grid. The generator network takes a input vector as an input. The vector is the weight intensity of the 8x8 grid images. The vector will have the weight intensity, not the images are not the pixels. It will have only the intensity. The intensity returned by the random function will not be in a finite value. It will be from minus infinity to plus infinity. But the discriminator takes only the values from plus 1 to minus 1. So we are going to use Lagrange function to convert those minus infinity to plus infinity values to minus 1 to plus 1. Here are the epochs given by the generative function. Here you can see the first image is too bit blurry and the second image is somewhat clearer than likewise, each epoch is a each loop. When we are giving higher epochs, we are able to get higher accuracy results. If the epochs are much higher, the images generated from the generated network will be much clear to fool the discriminated network. Like this, the discriminated network and the generated network work together and produce our real output.
So when it comes to the crucial part, that is training. So you can see the mathematical expression. You shouldn't say mathematical or mathematical expression. Artificial intelligence is generally mathematics. So we have two functions. One is log of first function and the log of second function. This is for the first, this is for the real one, and the second is for the fake one. So this whole function is wholly called as binary cross entropy. Okay. So the inputs given to this are, so first we can see this function is this h theta of xi naught. So this is the example in normal Python when you take sum of a comma b. So this is a function and we will return the value of sum. So now when you give h theta of xi, it gives the images to the discriminator function. So discriminator function, either it will get the real image from the data set or the generated image that was blurry shown before. So the images will be real image and fake image. The inputs will be real image and fake image. So we will calculate the loss. The total loss is real function. The real loss will be calculated in the discriminator and fake loss will be calculated in the generator. So we add both the losses and we try to reduce the number of losses to fool the discriminator. So as the number of epochs increases, the number of losses, the amount of loss decreases and we get a clarified image. So for training it, we pass real image as a function of the discriminator and fake image as a function of the generator. So we both add real and fake loss to get the overall loss. So gradient descent is used for updating the weights of the discriminator. So this function you can see we have used these functions to upgrade the discriminator model so that the weight gets updated and we get a proper weight so that it is ready to be fooled by the generator. So previously we have seen discriminator training and this is generative training. So who's fooling who? That is the concept. So you see generator is fooling the discriminator. So generator produces some weight. It should be good enough to fool the discriminator and make it say that discriminator is in low quality when compared to the generator. So these two are the functions used for updating the weights in the generator. So this is the final image. These images are not available in the data set. We have created these images. You can see some faces like diseases. That is because it has generated on its own from the collection of data sets that we have provided. So this is the third epoch and that is the seventh epoch. You can see it has some blurry, can you see? This has some blurry face. So seventh epoch has a fooling gas here. And you can see some eyes part here. So it has evolved itself and compared with the other data set parts and produced a new image. So when it comes to application, we can create new images to new profile tones. So this will be very helpful. So this is the final graph output we get. So discriminator, when we compare discriminator and generator, this is the part of generator, this is the part of discriminator. We said generator should fake the discriminator. It is almost nearing the discriminator, which really tries to fake the discriminator. So that is between real and fake, there is much gap because if you see the data set, it will be more clarified, but this is less clarity. So I will summarize the whole GAN network. So if you see, this is the data set, and this is generator, and this is discriminator. So if we give original data set here, it will be provided to the, as I said, h theta of xi is the function of discriminator. H theta of xi. This xi is the real image given here. So if we compare the fake image, this is also it's become 1.6. This will be given to the discriminator. This is the data set, this is the discriminator, and this is the generator. If we give this, here the both comparison will take place, and as this is a convolutional network, it will label it as 1 or 0. It will give 0 until generator fools the discriminator. So when 1 appears, these images appears depending on the number of epochs.
Okay. Now I'm going to discuss the problems we have faced while doing this project. Here you can see that we want to give the data sets while we are doing in a virtual environment. We all know that Google Colab works in a supercomputer somewhere else in the world. We have to give those data sets either by URL or from the computer we should upload images to that virtual environment. Okay. Now when we are uploading to the Google Colab, it says 9 hours left, 12 hours left. We don't know why this takes 9 hours or 12 hours left, because we have 1 lakh images. Then each epoch takes 5 or 7 minutes to do a build process. We have to at least 25 epochs to produce such a very image. If you are going to do 50 or 60 epochs with 1 lakh images, it is not possible to produce in a runtime provided to the Google product. So we came with a solution to take only 10,000 images from that 1 lakh images and upload it to the Colab. When we are trying to upload those only 10,000 images, even though it's this, we have to wait for 3 hours and 7 minutes. If you wait for 3 hours and 7 minutes, then we have to upload the next set of data set to compare the results. So we came into a solution. We directly zipped our folder and directly uploaded to Gravity. We created our own data set and uploaded to Gravity. And using the same principle followed in the previous step, we imported the data set URL and using the Gravity username and tag key, we imported as earlier. This is a problem we faced during our project. Hope this will help you while doing the problems. Thank you.